For decades, we've stretched our highways longer and widened our roads to make room for growing traffic. Yet, despite all our innovations, we've only ever moved sideways, but never upward. So, imagine a world where highways don't just connect cities on the ground, but are built in the sky, weaving between skyscrapers and floating far above the busiest streets. But how could we ever get to this point? In 2025, the idea of sky highways was still just a concept floating in the minds of visionaries and engineers. Urban centers around the world were facing increasingly severe congestion, and traditional solutions, wider roads, more lanes, were no longer enough. A handful of innovators began to explore the possibility of creating pathways in the sky. At this stage, discussions were mostly theoretical, with engineers, urban planners, and futurists debating how to make this bold idea real. The initial focus was on developing air lanes specifically for drones and autonomous flying taxis. Companies like Uber, Airbus, and smaller tech startups started experimenting with sky lanes, designated air corridors that drones could safely navigate. Governments were hesitant, but some cities like Dubai, Singapore, and Los Angeles started to show interest, offering limited airspace for experimental trials. By 2029, the first small-scale trials were underway. Companies began launching test flights for drone deliveries, with dedicated air lanes above industrial and commercial zones. These lanes were still relatively low, just a few hundred feet above the ground, but they marked the first real step toward creating highways in the sky. The focus during this period was on solving key challenges: traffic management, safety protocols, and reliable communication between autonomous vehicles. Early trials faced setbacks, including technical glitches, collisions, and weather-related issues. However, these experiments provided valuable data, helping engineers refine the systems. Governments also began to draft the first set of regulations for aerial traffic, similar to the rules of the road we have for cars. These early regulations paved the way for more ambitious projects, encouraging private companies to invest further in the technology. By 2035, the vision of sky highways began to take shape. What started as limited trials had evolved into functional, commercial air lanes for autonomous flying taxis and cargo drones. Cities like Tokyo, London, and New York began building skyports, multi-level hubs that connected ground transportation to these new aerial routes. Technological advancements during this time played a huge role in making this possible. Improvements in AI, sensors, and electric propulsion systems allowed vehicles to navigate crowded airspace safely and efficiently. Traffic management systems, using AI and real-time data, could now predict and prevent potential collisions before they happened. Yet, the system was far from perfect. Challenges such as energy consumption, weather resilience, and ensuring safety standards remained, but the benefits were becoming clear. Sky highways were reducing congestion on the ground, speeding up deliveries, and offering a glimpse into a future where the sky was no longer the limit, but the new frontier. In 2036, the first commercial sky highways officially launched. The initial focus was on connecting high-traffic areas within cities, such as business districts, airports, and logistics hubs. These routes were limited in scope, but proved the concept was viable. Companies like Tesla, Boeing, and Airbus led the charge, creating electric, vertical takeoff and landing (eVTOL) vehicles specifically designed for urban environments. By 2040, several cities had established regular routes for flying taxis and cargo drones, with a few daring to set up intercity connections. Skyports started popping up in more urban areas, becoming a part of the cityscape. These ports acted as charging hubs, maintenance stations, and boarding points, making air travel as convenient as catching a bus. 2041, expanding the network. Between 2041 and 2045, the focus shifted to expanding these air routes to connect more cities and regions. Highways in the sky were no longer just an urban solution. They were starting to link major metropolitan areas, reducing travel times from hours to mere minutes. As the network grew, so did the complexity of managing air traffic. Companies collaborated with governments to develop a unified air traffic control system for the sky highways. This was a massive undertaking, requiring advanced AI and machine learning to handle thousands of vehicles simultaneously, predicting and avoiding potential collisions in real time. Challenges remained, But the dream of a comprehensive network of sky highways was starting to take shape. By 2046, the need for integration between ground and sky transportation became crucial. Skyports were redesigned to act as multi-level transit hubs, connecting air routes with trains, buses, and traditional roads. This integration allowed passengers and cargo to move seamlessly from the ground to the sky, making transportation faster and more efficient than ever before. This period also saw the development of new infrastructure to support sky highways. Specialized sky lanes were marked out above highways and urban areas, designed to manage different types of vehicles, from personal air cars to cargo drones. Urban planners faced the challenge of balancing air traffic with the needs of city residents, ensuring the skies didn't become as congested as the streets below. 2051. Addressing technical and environmental challenges. Despite the growing popularity of sky highways, there were still significant technical and environmental challenges. Powering a fleet of flying vehicles required vast amounts of energy, and traditional batteries weren't efficient enough for long-distance travel. The industry began investing in alternative energy sources, such as hydrogen fuel cells and solar-powered eVTOLs, to make sky highways more sustainable. Environmental concerns were also at the forefront. Critics warned about the potential noise pollution and the impact on wildlife, particularly birds. To address this, engineers worked on quieter propulsion systems and advanced navigational AI that could detect and avoid wildlife. These innovations were essential for gaining public trust and ensuring the long-term viability of sky highways. By 2056, a major breakthrough came in the form of advanced propulsion and energy systems. The limitations of traditional electric batteries had been a bottleneck, but new technologies like hydrogen fuel cells, magnetic levitation, and even solar-absorbing surfaces started to change the game. These advancements allowed vehicles to fly longer distances, recharge quickly, and reduce their environmental impact. During this period, new materials were also developed that made sky vehicles lighter, more efficient, and safer. Composite materials that could withstand harsh weather conditions and high altitudes became standard, ensuring that sky highways could operate even in challenging environments. Between 2061 and 2065, safety became a top priority as the number of vehicles in the sky increased. AI-driven systems played a crucial role in managing traffic, predicting and avoiding potential hazards, and coordinating thousands of autonomous flying vehicles. The development of predictive maintenance systems also emerged, allowing vehicles to self-diagnose issues before they became critical. Real-time data sharing between vehicles, skyports, and air traffic control centers ensured a high level of safety, minimizing the risks of accidents and mechanical failures. These improvements reassured the public, encouraging more widespread adoption of sky highways. By 2066, sky highways had become a common feature in many cities across the world. The network expanded rapidly, connecting major cities, regional hubs, and even rural areas. For the first time, people could live far from urban centers and still enjoy fast, reliable commutes, changing the dynamics of housing, work, and lifestyle. The mass adoption led to increased competition among companies, driving innovation and bringing down costs. What was once a luxury for the wealthy was now accessible to a broader segment of the population. Skyports became as ubiquitous as gas stations, and cities redesigned their layouts to accommodate this new mode of transport. The period from 2071 to 2075 saw an economic boom fueled by the widespread adoption of sky highways. Entirely new industries emerged around the concept, from maintenance and support services to luxury sky tours. The logistics industry was transformed, with goods moving faster and more efficiently than ever before, cutting down delivery times and costs. However, this growth also brought challenges. Concerns over airspace congestion, energy consumption, and environmental impact led to new regulations and standards. Governments and private companies worked together to find solutions, ensuring the expansion of sky highways remained sustainable and equitable. By 2076, engineers began exploring the concept of superhighways, high-speed routes positioned at higher altitudes, designed for long-distance travel. Unlike the lower sky highways that operated within city limits or regional routes, these superhighways were built for intercontinental travel, allowing passengers to move between cities, countries, and even continents at unprecedented speeds. These routes utilized advanced propulsion technologies, including magnetic levitation and ultralight materials that could sustain high-speed travel at elevated altitudes. The superhighways were a glimpse into a new age of aviation, bridging the gap between traditional air travel and everyday sky highways, and hinting at future possibilities for near-space travel. As sky highways became an essential part of urban life, new innovations emerged to make them even more efficient and reliable. Automated maintenance systems were developed, with drones and robotic systems responsible for inspecting and repairing infrastructure. This minimized downtime and ensured the highways were always safe and functional. Additionally, adaptive infrastructure became a reality. Sky highways could now dynamically adjust lanes and routes based on real-time traffic data, weather conditions, and other factors. This made the system more resilient and responsive, reducing congestion and improving overall efficiency. By 2081, the global economy was redefined by the efficiency and speed of sky highways. Industries like logistics, tourism, and emergency services thrived, taking advantage of faster and more flexible transportation routes. This connectivity also encouraged international trade, making it easier to move goods across borders and fostering global collaboration. However, the rapid growth brought new challenges, such as managing the environmental impact and ensuring fair access to the infrastructure. Governments introduced new regulations to encourage sustainable practices, and companies invested in green technologies to make sky highways more eco-friendly. The decade closed with the sky highways as a symbol of innovation, connectivity, and the boundless potential of human ingenuity.